we can stress enough on the point that the universe is really weird. For as long as any of us have been alive, we've been told one story about how it all started. It begins 13.8 billion years ago with the Big Bang. From a single point, everything we are, everything we see, expanded into the cosmos we know today. It's a story we thought was solid, confirmed by decades of science. But what if that story is wrong? What if the rule book for the universe needs a serious rewrite? Our most powerful eye on the sky, the James Webb Space Telescope, is peering back to the dawn of time, and it's finding things that just shouldn't be there. It's spotting galaxies that seem way too massive, too bright, and too well-formed to exist so early on. These aren't just little glitches, they are cosmic oddballs that are genuinely challenging our most trusted theories. And this isn't just some quiet debate anymore. When a Nobel Prize-winning physicist, one of the people who wrote the rule book, says we might have, quote, misunderstood the universe, it opens the door to some truly wild possibilities. The kind of possibilities that suggest these strange galaxies might be more than just galaxies. They could be hints of something else entirely. Okay, so to get why these new discoveries are so earth-shattering, you first have to understand the story they're messing with. For about 50 years, cosmology has been dominated by one idea, the Standard Model, also known as Lambda CDM. Think of it as the official prize-winning history book of the universe. It's been incredibly successful, explaining the leftover heat from the Big Bang, the cosmic microwave background, and the giant web-like structure of galaxies and dark matter. It gives us a neat timeline for everything. The story goes that right after the Big Bang, the universe was a hot, soupy mess. For about 380,000 years, it was an opaque fog. Then, atoms formed, light broke free, and the universe entered the cosmic dark ages. For millions of years, it was just dark, no stars, no galaxies, just huge clouds of gas. Then, gravity started doing its thing. Gravity is patient. It began pulling together the densest bits of gas. The standard idea is that this was a bottom-up process, like building a giant Lego castle. You can't start with the whole castle. First, you need individual bricks, the first stars and dark matter halos. Then you build small sections, the baby galaxies. Only after hundreds of millions, even billions of years of smashing these sections together do you get the huge, majestic castles we see today. This takes time, a lot of time. Our models were clear.
You can't get a big, mature-looking galaxy for at least 1 billion years. There just wasn't enough time for gravity to assemble all the pieces. And this is exactly what the $10 billion James Webb Space Telescope was built to prove. It's a time machine designed to see the universe's first Lego bricks and confirm our construction manual was correct. Webb opened its golden eye, and almost immediately, that neat, elegant story started to look shaky. The first images weren't of tiny, disorganized clumps. Instead, what Webb saw in the infant universe was shocking. Monsters! Imagine you're an archaeologist who knows for a fact that complex cities only appeared after thousands of years of small settlements and simple tolls. Now imagine digging down to a layer you know is 10,000 years old, expecting to find stone arrowheads, and instead you find a smartphone. That's pretty much the shock that hit astronomers. Webb was finding the cosmic equivalent of a smartphone in the Stone Age. They've even been nicknamed impossible galaxies. One of these cosmic oddballs, spotted just hundreds of millions of years after the Big Bang, was a galaxy that already looked surprisingly massive and full of stars. According to our models, it should have been a tiny, chaotic mess. Instead, it was a behemoth. This find challenges the whole timeline, which needs dark matter halos to form first before a galaxy can even get started. This thing just showed up to the party way too early. And it wasn't a one-off. It's a pattern. Everywhere Webb looks into the dawn of time, it's finding that early galaxies are far brighter and more numerous than even the most optimistic models predicted. In some cases, up to 10 times more than expected. They're everywhere. Scientists, of course, tried to explain it away. Maybe they just look massive because of a weird temporary burst of star formation. maybe it's just cosmic dust messing with the readings. But as the data keeps coming in, those simple explanations are looking less and less likely. The problem is not going away. This cosmic headache is piled on top of another long-running mystery, the Hubble tension. For years, we've had two different measurements for how fast the universe is expanded. It's like trying to find out how fast a car is moving using two different methods. One method is like a radar gun, measuring the car's speed right now by looking at nearby objects like stars. The other method is like calculating the car's speed based on the factory specs of its engine, in this case by studying the afterglow of the Big Bang. Both measurements are super precise, but they give you two different speeds. They don't match. Everyone hoped Webb would fix this. It did the exact opposite.
Webb's data just confirmed the radar gun's measurement with even more certainty. The disagreement is real. The beginning of the universe and the universe today are not adding up. Scientists are completely stumped. When your trusted theory starts to show cracks this deep, you listen very, very carefully to the people who built it. One of those people is Adam Rice. This is a guy who won a Nobel Prize for co-discovering dark energy, the very thing that's making the universe expand faster. He's a key architect of the standard model that's now in trouble. With Webb's new data confirming the Hubble tension, Rice said something that sent shockwaves through science. With measurement errors negated, what remains is the real and exciting possibility we have misunderstood the universe.
Think about that. This isn't some rogue scientist. This is the establishment admitting the foundation might be cracked. And he's not alone. John Mather, the lead scientist for the Webb telescope itself, and another Nobel winner, admitted the early galaxies they found are not quite like what we thought they were, and are surprisingly big and bright. These warnings have cracked the door open for ideas that used to be on the fringe. If our physics can't explain what we're seeing,
maybe we need different physics. And that brings us to Sir Roger Penrose. Penrose is a legend. He won his Nobel for proving that black holes are a definite consequence of Einstein's theories. But he's also championed a wild, mind-bending idea called conformal cyclic cosmology, or CCC. Imagine the universe not as a single event, but as a phoenix, endlessly being reborn from its own ashes. Penrose suggests our Big Bang wasn't the beginning, but just one eon in an endless cycle. In his view, each universe expands until everything in it has evaporated into pure energy. At that point, the vast, empty future of one universe essentially becomes the hot, dense Big Bang of the next. The end of one cosmic era triggers the birth of another. For years, this was just a cool idea you couldn't test. But Penrose argues there should be evidence left over, faint traces from the black holes of a previous eon imprinted on the cosmic microwave background of our own. He and his team even believe they've found hints of these Hawking points in the data, though this is still a very hot debate. Now, connect this radical theory to what Webb is seeing. The data gets weird, so the theories have to get weird too. If these ancient giant galaxies can't be explained by the timeline of our Big Bang, what if they aren't from our Big Bang at all? What if they are relics that were somehow seeded by the cosmos that came before ours? These galaxies might not be impossible if they got a cosmic head start. The idea that we're seeing leftovers from a past universe is a huge leap, but once you go there, even stranger ideas get a seat at the table. What exactly are we looking at? Penrose's cyclic model is one option, but modern physics has other ideas, like the multiverse. You've seen it in movies, but it comes from real theories. One version suggests our Big Bang was just one bubble in a larger, eternally inflating superspace where new universes are popping into existence all the time, maybe with totally different laws of physics. Another idea from quantum mechanics is like a video game that creates a new save file with every possible choice. It suggests the universe splits into parallel worlds with every quantum event, creating an infinite number of alternate realities. Until now, this was basically philosophy. How could you ever test it?
Webb can't just turn and take a picture of another universe. But some physicists think if another bubble universe bumped into ours, it might have left a sort of cosmic bruise on the microwave background, or caused weird structures to form that our own physics can't explain. And that brings us back to the data. When astronomers see galaxies that are too big, too soon, they have to ask, is this a problem with our model of time? Or are we seeing a fingerprint from something outside? Let's be absolutely clear. This is the bleeding edge of speculative science. No one is saying Webb has found definitive proof of the multiverse. But what's changed is that the data is so strange, so hard to explain, that these once fringe ideas are now part of the conversation. The struggles of the standard model are forcing scientists to consider the exotic stuff. What if the Big Bang wasn't the beginning, but just our beginning? What if the laws of physics themselves were different in the early universe, allowing for a flash of super-efficient galaxy building before they settled down? These are the questions keeping cosmologists up at night, born from the paradoxical images from our golden eye in space. These questions are what push science forward. The James Webb Space Telescope wasn't just built to confirm what we knew, it's become an engine of revolution, forcing us to face the edges of our knowledge. And if your mind is as blown as ours, smash that like button and subscribe. We are living in a new golden age of discovery, and you won't want to miss what comes next. Let us know what you think these mysterious objects could be in the comments below. Are we just seeing new physics we don't get yet? Or is this the first real hint of something beyond our own universe? The James Webb Space Telescope was sent up there to answer some of our oldest questions. We thought it would fill in the last few pages of our cosmic history book. But in a twist no one saw coming, it hasn't just given us new answers, it's thrown out our old questions and given us new ones that are way stranger and more profound. The impossible galaxies, the Hubble tension, the warnings from Nobel laureates, it all points in one direction. The simple story of a single Big Bang might just be that, a story. The reality seems to be far more complex. The old map of the cosmos is being ripped to shreds. We've reached the edge of what we know, only to find the ocean is bigger and weirder than we ever imagined. The universe isn't broken, our understanding of it is, and the journey to fix it has only just begun.